Okay, so this example is given e raised to log of something. Okay, so we will learn now how to solve this particular problem. So it is the example of the composite functions because e raised to log of these two are complement of each other. So we can think that these two can cancel each other. E raised to exponential of the logarithmic term will cancel each other because they are exponential. Okay, so if I put y is equal to this particular term, so it is a log of x its square minus log of x square. Okay, so these two will get cancelled, and finally I will get y is equal to log of x its square minus log of x square. Okay, so there is a difference between these two. Log of x its square means log of x multiplied by log of x, and log of x square means log of x into x, like that. So we will take the derivative on both the sides. So I will get the dy by dx equal to dy by dx is equal to derivative of this particular term. So d by dx derivative with respect to the x. So log of x its square minus log of x square. So the derivative of the square, now it is a composite function. The first function is a square function and the second function is a log function. It is a composite function. It is a normal function. I think it is also the composite function. Derivative of x square, first of all derivative of the log and then the derivative of the square, like that. So I think this square will come in a multiplication and it is only one function. It is having one. We will simplify this particular term first of all. So first one is a composite function and second one is a normal function. So derivative with respect to the x is equal to, we will keep it as it is, log of x its square minus 2 will come in multiplication and it is a log of x because it is a rule of the logarithmic. Okay, indexing rule of the log is that whenever there is a power it will come in a multiplication. And now it's simple. So derivative of the two terms and their derivative of the two functions and which are there in addition is equal to their individual derivative. So we will take the derivative of this particular term. So power will come in multiplication and power will be reduced by 1, and after that okay, so let's take the derivative of this particular term. So it will become power comes in multiplication, or take the individual derivative of the log of x its square minus 2 times derivative of the log of x. So it will become, so dy by dx equal to derivative of this particular term. Power will comes in multiplication and then the power will be reduced by 1. It is the derivative of the first function, square function. Now the derivative of the second function. Now the derivative of the log of x. So the derivative of the first term is over. Now the derivative of this is minus 2 and derivative of the log of x with respect to x is 1 upon x. Right. Now it's simple. Now the derivative of the y with respect to x is equal to 2 times log of x. Derivative of the log of x is 1 upon x. minus 2 divided by x. So it will become 2 times log of x minus 1 divided by x. So it is the final derivative. Now look at this particular expression, x raised to 2x. Okay, so exponential form is there, and in a base also we have the x term, and in index also we have the x term. So somehow we have to split this particular base and the exponential, and we have to differentiate it with respect to the x. Means if we consider y equal to x raised to 2x, so base also has the x and index also has the x. Okay, so we have to somehow split, we have to convert this exponential form into the multiplication form, and this is achieved using by taking the log on both of these sides. So whenever I take the log on this side, so it will become log of y, and it will become log of x raised to 2x. So 2x will come in multiplication and multiplied by log of x. So now it becomes simple now. So log of y equal to 2x into log of x. So 2 is a constant. So there is a multiplication of the two functions, and we know how to take the multiplication, how to take the derivative of the function which are in multiplication with each other. So we have that separate formula. So now we will take the derivative on the both the sides. So it will become the dy by d derivative with respect to the x of the log of y is equal to derivative with respect to the x of this particular term. Now with respect to the x, so derivative of the log is 1 upon y, and derivative of the log is, and derivative of the y is dy by dx. So here we have the composite function. This is what here you will find the composite function. So sometimes the composite function will present in right hand side or in a left hand side also. So now this time the composite function is available on a left hand side. So it is a composite function. So there are two functions, log and y. Then take the derivative of this particular, so it will become 2 times the derivative of the two functions which are in multiplication with each other. So we will keep it as it is. So dy by dx, that is what we are expecting, is equal to y times 2 is a constant, so we will take this outside the bracket. The derivative of this particular term, x into log of x. So dy by dx is equal to 2 times y. So first function is the x, which is as it is, into derivative of the second, plus second function as it is, into derivative of the first, which is 1. So dy by dx is equal to 2 times y. So this x and x will get cancelled. So 1 plus log of x. So it is equal to the 2 times y means x raised to 2x. So 1 plus log of x, and I think this is the final derivative. Okay, so it is also again one of the complex example, x raised to something, and again that's something raised to x. So if I consider y equal to x raised to something, and then something raised to again x raised to some constant, and again that's some constant raised to again the x variable. So if I want to differentiate it with respect to the x, then it becomes difficult because the variable for the differentiation is the x with respect to x, and that is coming in base also and in index of index also. So anyhow we have to break this particular chain. Okay, so for that we have to apply the logarithmic on both the sides. So log of this y is equal to log of x raised to 4 raised to x. So it will become 4 raised to x multiplied by log of x. Now it becomes the simple formula. So it is a first function, some constant raised to x, it is the first function, and log of x, it is the second function. So two functions are in multiplication, so we can calculate the derivative of this particular. Now here we have the composite function. So log is the first function and y is the second function. Here we have got the second composite function. So we will apply the derivative on the both of this particular side. So derivative with respect to x of the log of y equal to derivative 4 raised to x into log of x. So 1 upon y into dy by dx equal to first function as it is, derivative of the second function plus second function as it is into derivative of the first function, right? Now 1 upon y dy by dx equal to 4 raised to x as it is, derivative of this log of x is 1 upon x plus log of x as it is, and the derivative of constant raised to x is equal to a raised to x, means like that. So 4 raised to x into log of 4, like that. So that's done, I think. So 1 upon y, then the dy by dx equal to 4 raised to x divided by x plus 4 raised to x into log of x into log of 4. So dy by dx equal to y times, if I take the 4 raised to x common, so it will become 1 upon x plus, so 4x is common, so log of 4 times log of x, and this y. So y is equal to, we know. So we have to just replace the value of y here. So derivative with respect to the x is equal to x raised to 4 raised to x. 4 raised to x, 1 upon x plus log of 4 log of x. That's complete. Now sine of x raised to x, okay, variable of the differentiation raised to again variable of the differentiation. So again we have to apply the logarithmic rule. So y is equal to sine of x raised to x. So if we apply the log of y and log on this particular term, sine of x raised to x, so 1 upon y and then the dy by dx is equal to I think we have to first of all simplify this. So log of y equal to, power comes in multiplication and then the power is reduced. No, it is a logarithmic rule. So power in the index will come in multiplication. Now it's okay. Now it is the composite function. Yes. So composite function is present here also. Log is a one function, y is the second function. Here there is a two terms. So first function is a f1, second function is a f2, and second function is a composite function. It consists of the log function, it consists of the sine function. Okay, so we have, like this, we have to analyze the problem and then we have to solve that particular problem. So we will take the derivative on both of the sides first of all. So 1 upon y and then the dy by dx is equal to, first function is as it is, derivative of this particular second function, plus second function as it is, and the derivative of the first function, that is x only. Just we have to solve this particular. So 1 upon y dy by dx equal to x as it is. Derivative of this log term is 1 upon sine of x into derivative of this particular sine function plus log of sine of x. Derivative of this x is 1. So 1 upon y dy by dx is equal to x into 1 upon sine. Derivative of the sine is cos plus log of sine of x. So dy by dx is equal to y times, so x into cos of x divided by sine of x, so it will become cot x plus log of sine x, and y is nothing but sine of x raised to the power of x multiplied by x into cot x plus log of sine x dy by dx. That's done. Okay, so initially whenever we look at this particular expression in this particular problem, we will find that it is difficult, but if we analyze the problem, then it will become simple one. First of all, we will analyze the problem. So we have to differentiate with respect to the x. So variable for the differentiation is the x. Okay, so we can see that there is the addition of the 4 functions. It is the function 1, function 2, function 3 and the function 4. So whenever I want to take the derivative of this particular example, so I have to take the individual derivative and then we have to add that particular derivative. That's simple one. Okay, now look at the e. So e is considered as a constant in mathematics. So e raised to e, looking at this particular function, so constant raised to constant will finally give you the constant term. So derivative of this constant is always a 0. So it is over now. So again we have only the 3 functions, f1, f2, f3. So e raised to x means constant raised to x, a raised to x formula. So a raised to x into log of a means e raised to x into its derivative will be e raised to x into log of e. So finally log of e means it is a 1. So finally we will get the e raised to x. Right? So for the f1, x raised to e means x raised to some constant is equal to, constant comes in multiplication and then the constant will be reduced by 1. Okay, so just we have to take the addition of this plus this, addition of this term plus this term plus this term plus derivative of this particular. Now here we have to apply some rules. X raised to x is there. So variable for the differentiation raised to variable for the differentiation. So we will first of all consider this term f2. U is equal to x raised to x. Then we will find out the derivative of this x raised to x and then we will add it. So for that, let's say let u is equal to x raised to x and then the derivative of the u with respect to the x? No. So first of all, we have to apply the log rule. So log of u is equal to log of x raised to x. So it is equal to x into log of x. Now it's simple function. Okay. So derivative of the multiplication of the two functions. So 1 upon, here we have to use the composite function. So in this particular example, in total we have the concept of we have to use the concept of the composite derivative here. So 1 upon u into du by dx is equal to first function as it is, derivative of the second, plus second function as it is into derivative of the first. So it will become du by dx is equal to u means x raised to x into this will cancel. So 1 plus log of x. Right. So if I consider this is equal to the y, so if y is equal to x raised to e plus x raised to x plus e raised to x plus e raised to e, then the derivative of this y with respect to x is equal to the derivative of x raised to e, x raised to x, e raised to x, e raised to e. Okay. So finally we will get the output. So derivative with respect to the x is equal to derivative of this, power comes in multiplication, power will be reduced by 1 plus derivative of this term we have calculated. Derivative of this term is a raised to x into log of a into derivative of e raised to x is 0 because it is a constant. So dy by dx is equal to e into x raised to e minus 1 plus x raised to x 1 plus log of x, then plus e raised to x because log of e derivative is 1.